Hey everyone, and hopefully everybody is doing very well out there still. Now, welcome to part number 2 of this series, the restoration of our Fender Brownface Deluxe Amp from 1962 or 63. And for those who missed part 1, where we disassembled the amp and inspected all of the parts, and we made a plan how to work on the electronics and what to do to make it safe and sound again. Here's briefly the plan again, what we're going to do to this. We're going to do a thorough cleaning of this amp. We're going to put a 21st century ground system in it, and we're going to recap this thing. So what we're going to do is we will place the electrolytic capacitors. These are probably, this is probably already recapped somewhere in the 70s, so these are a little bit now outdated. So we're going to recap this and replace these electrolytic capacitors with 25 microfarad at 25 volts, and we will place this capacitor in the bias section with 25 microfarad at 50 volts. We're going to delete our death cap circuitry. We will leave the ground switch, of course, sitting in the chassis because it looks nice and it makes the amp complete. You can always revert back to original if you need to, but this is a very dangerous system. Later on we will inspect this and I will show you why this is a dangerous system. So we're going to put a 21st century proof ground system in there. We're going to clean all of the pots, of course. We're also going to replace this diode here, which is a little bit of a weird thing. It looks like an industrial type of diode or something. We're just going to replace this with a very neat new diode, and we will discard of these parts. Of course, we will keep everything in the box. I think the original diode is still in there, clipped off. On the other side of the amp, of course, the electrolytic capacitors, where we saw that these two are leaky. This is probably already a replaced one, and this is probably still functioning. Anyway, we're going to discard of these, and we'll keep them. It also looks like very weird industrial type of capacitors. So we're going to replace these with some new FNT capacitors in the values 22, 22, 22, and a 15, and we'll replace the voltage dropping resistors. We're going to clean our tube sockets, and we're going to see if we can tighten the pins on the output tubes, their sockets, to make sure we have some tight connections there and the tubes are not going to be rocky. Let's see, did we forget anything? Yeah, we might end up tidying a few of these. These look a little bit long. It's not entirely necessary, but these are high voltage wires. It's not so nice to have them hanging there in the breeze. Let's see. Yeah, I think that that's gonna be it. In the future, it might be a very good plan to hunt down some original Ajax 0.1 microfarad tone capacitors and see if we can replace these mustard caps. These mustard caps belong in Marshall type of amplifiers. Okay, in a way, this is like a tiny blues breaker, kind of a Marshall, if you want to, but yeah, these are obviously already replaced capacitors and they don't belong in this amp. Okay, yeah, I think that's about it. Okay, the very first thing I'm going to do before I start spraying and start soldering is take a vacuum and gently vacuum this out with a vacuum set on the lowest setting with a brush type of thing to just make it as clean as we possibly can before we start working. Let me quickly show you a couple of funny things. I mean, I was inspecting the circuitry a little bit more in detail and I saw some, I don't know if you can see this here, but this here looks like a clipped off wire, as if there would be something here, but this is actually a correct original wire, and it's probably the other side of it, just pulling through here, where it connects to pin 4 of this output tube here. Also here, this looks like a clipped off wire, and yeah, that can look really scary. You would say like, oh no, that's a modification, something was here before, but this is actually going to be a correct to pin 7 lead going under the board and coming through here. There's a couple of connections that look a little bit dry, maybe cracked. We have to really look. I mean, for this, you can see here this resistor is not completely floating in the connection, but you can see actually that this connection is cracked. So we have to probably just reheat those old solder points and just make sure we are really safe and sound on those. Okay, that gave me a very satisfying feeling. let's now start on the replacing electrolytic capacitors. We start on this side. Needless to say, you have to of course make sure there's no residue voltage left in the amp. Of course, before you start working, you have to make sure your filter capacitors are drained. How do you drain your filter capacitors? You basically short your positive to the chassis. You do this using a drain cable, like a little cable with a resistor in it, to make sure there's no sparks. You can actually also short these things. That's not a very beautiful way, and you also drain those capacitors a little bit too quickly. The best way to do this is to use a drain cable and place your drain cable on pin 1 of V1. This is your very first preamp tube. If you then connect your drain cable to your chassis, it's going to just very slowly drain your amplifier. Now this amplifier is already drained, so it's safe to work on, but that's how you can do it. Maybe in another video I'll make a tutorial on how to do this. Here's a basic soldering tip. We wet the soldering tip like that. Then we're going to be able to transfer the heat more easily. We're going to be able to, with less effort, desolder these connections. And here's our first pulled out electrolytic capacitor. We're going to replace this with a Sprague Atom one. With this one. These are nice quality capacitors and they should last a long time. Now the old capacitor had pretty weird, very long leads. I mean, just not really tidy. We're going to try to bend a really nice short leads to make it fit really nicely into our chassis. Something like this. And then it's gonna look like this. The negative is going to go that side and the positive this side. And that looks quite nice, I think. Okay, the electrolytic capacitors on this side is done. Let's do the bias section. So see, this is a pretty weird capacitor and this is a pretty weird diode mess. It's already disconnected just moving it. So yeah, we know we have some work to do there. Let's start with this diode stuff. Okay, I tried to be tidy, but it's a bit more difficult. Then we'll do our capacitor. That's a weird capacitor. 25 microfarads at 70 volts. Looks also a little bit like industrial. Okay, out comes the capacitor. And in goes this nice Sprague 25 microfarads at 50 volts. Before we do that, we're going to measure our 22K resistor there. We have a little bit more space. Yeah, I know it's a bit of a shitty meter, but it's all that I have today. 23.4. That's within tolerance, but usually they measure a little bit higher than in real life. Now let's say there's a 5% tolerance on these with 22K exact. Then 5% will be 1K extra, so I think we're good there. With the capacitor here we have to pay a little bit more attention because the positive side is going to be wired to the ground side of the bias circuit. Okay, now the bias circuitry is also done. Try to be as neat as possible to also make it like visually appealing. Let's take a look at this death cap circuitry. So here's our death cap circuitry. It's pretty dangerous. For those who know how basic electricity works, this might be already very striking. You see the plus from our net cable, the plus from the wall, which is actually not really connected properly either. It's going to a chassis. Now you would say, how would you connect the plus? How would you connect the hot of our net voltage to the chassis? Well, it works like this. This is our ground coming from our net cable. It's switched, so you can actually disconnect the ground. We are protected with this capacitor. The hot will not literally go to the chassis per se because it's going to be blocked to one side with this capacitor, hence the death capacitor. If this capacitor fails, our net voltage of 230 volts is going to be on the chassis. So yeah, that's not a very nice system to work with. It's just a very unnecessary, very high risk. So here's what's going to happen. We're going to disconnect all of this and we're just going to hook it up the proper way. We're going to take our ground cable, and our ground cable is of course going to our star ground to the chassis. That's going to make a lot of sense to begin with. Then going to take one hot lead, which is going to the fuse holder directly. It doesn't need to go to the ground switch anymore. It can just be hooked up to the fuse holder directly. And the other side is going to go to the switch, which is going to switch through our center of the transformer. And that's basically all we have to do to make a safe, regular power supply. We do need to install some sort of grommet here because, as you can see, it's flapping in the breeze. It's also pretty stupid to do it like this. I mean, if you would pull on your cable, you would pull directly on components in the amp. This is probably why this got sort of disconnected. That's just really dangerous, and we are going to try to correct all of these things. Okay, we have removed our cable. We are now ready to hook it up again in a safe way. I think we are going to reuse our ground switch after all. We're going to use one side and hook it up to our power switch via this original wire, so we don't necessarily remove original stuff. Okay, I restripped my power cord and try to just do a neat job. I'm going to start with our ground cable and J-hook it to this nice eyelet here, so we have a very safe mechanical connection to begin with, like that. Let me see if I can zoom in a bit so you can see it. See? Okay, before we start soldering, I'm going to try to first make this not really tight. Those are the basics. No, that is tight. Like that. That all looks much better. So nicely we have our one side of our power transformer coming nicely under this, and that's a little bit shorter now and it's tidy. And then one side of our power cable goes to the fuse, and one side of the power cable is going to our switch, which is going to switch to our power transformer. Okay, I went ahead and I zip tied my cable to this ground switch, so that comes in handy now. And now that's very nice and solid. And I think this is a good solution for now. So we have everything we need. I think we can now continue to the filter cap side of things. Okay, I'm going to start by measuring the voltage dropping resistors there. This should be 27k, and this one checks out exactly. It's exactly 27k. It couldn't be more accurate. So it's probably maybe, let's say 1k off. I'm gonna leave that one for the sake of originality. This should be 10k, it's 9.6. That's also within tolerance. And this one should be a 1k. And it is. Yeah. You know what? Maybe I'm gonna just tidy this one up. I mean, it looks a bit nasty. It's not so nicely done. There's big soldering blobs on there. And I think we can do a little bit of a better job. It's a 5.5 watt as well, so it's a pretty sturdy one. I think we're gonna just have to leave it in place. Yeah, almost forgot. These leads run under the board, so we can unscrew this and see if we can easily take them out neatly, and otherwise we have to clip them off. Here's how it looks under the board. So yeah, this the leads of the Astrons are actually providing the connection. So I think we're going to cut them off in the end, so we can leave this connection, tidy this up a bit. We're going to just cut them off in a way that you won't see it anymore. Okay, now here's how it's gonna go. We got our 15, and then we're going to have 3 22s. And let's try to do a neat job there. It's always nice to keep our lettering facing up. That looks the most spectacular. That's one. That's two. The amp is now recapped. I'm pretty pleased with this. We're now going to start spraying the tube sockets and then see if we can tighten the pins on these. Cleaning tube sockets is a pretty basic process where you just would put a tube in and take it out again. Now I'm not going to do that with our vintage tubes that we took out of this amp. I'm just going to take a non-critical, a little bit of a faulty tube and start cleaning it like that, you know. This one is still good. Yeah. Yeah. It's not that bad. The tube is slightly rocky. I'm gonna take one end of a multimeter probe and see if I can very slightly. Yes, sweetie. Stick them in there and just tighten them up just slightest bit. even though you can move the tube, you're actually moving the whole tube. You're moving all of the pins at the same time. Back on the amp side of things, we're going to clean the inputs. I'm going to clean the potentiometers. And that's going to be a very straightforward process. We're going to just spray these a bit, and you can actually use a pipe cleaner, but I'm going to use a jack cable for this. Okay, now we're going to repeat the process. It's so fantastic how new these inputs feel, you know. These are not worn out at all. Going to just one more time on the hot of these. Okay, well, is this now technically overhauled? Maybe it is. So what did we do? Just again, we replaced the electrolytic capacitors on the circuit board. On the bias circuitry, placed a new diode. We corrected our death cap circuitry and put a 21st century normal ground system in it. We cleaned the potentiometers and the jack inputs, and on the other side replaced the filter capacitors, and we tidied these up, and we also cleaned the tube sockets. I think that's it. What we can still do now when the amp is out of the thing, maybe we can clean up our faceplate before we hook it up to a speaker and do our fire test. I'm doing this with a super gentle glass cleaner, and I didn't want to disassemble this stuff. So I'm gonna just try to do a neat job with all the stuff still assembled. I think it should be good. Insane. I'm gonna finish this off with some turtle wax, I think. Okay. Well, a little problem, the faceplate is now looking so fantastic that the knobs are actually sort of standing out as a little bit more dirty, and I cannot really clean them properly. So in the end, I think I do have to remove them to clean them separately. And let's do that quickly. And that, of course, gives the opportunity to go on a little bit more and do this bit with the knobs off. That's actually a better plan. It's pretty incredible how this looks. So we now have to actually be very careful doing our jack in and outs while playing, because you don't want to scratch this sort of historic faceplate. I cleaned these knobs. They all have a very beautiful, nice little sheen on them. They were actually pretty cruded. Okay, let's put these back. And yeah, this faceplate is definitely an asset of this amp. Okay, then we are actually ready for fire tests. At the moment of filming this, our cabinet isn't ready yet. So what we're going to do is we're going to hook it up to our replica cabinet that houses a nice blue Alnico speaker, which is a great speaker to test this on. And we'll see if it fires up again, and we'll see how it sounds. I'm very happy with this actually. We got a great vintage amp here, and it's going to have a future now. So let's see how it does. Thank you very much for watching part number 2 of this series where we overhauled this amp. I'm gonna do the sound check, the bias and the tube work in part 3 of the series, separate video. Otherwise everything is going to be way too long, as I'm now in the midst of editing this. So for those interested in the first fire test, the first sound check, and to see how the tubes are biased and the bias work and tube work, we can now go on to part number 3. See you guys there. Have a great weekend, you all. I have no idea which day it is now.